Alright, in this video we're going to take a quick look at the Chapter 5 summary. This is going to go over all the things that you've learned, but very quickly and without examples. The first thing is to remember that with inequalities, you treat them the exact same way as you would treat an equation when solving, except, and this is a huge major exception, you flip the inequality sign when multiplying or dividing by a negative number. So for example, if you have 3x is less than 21, let's make that a negative 3x. So negative 3x is less than or equal to 21. You want to get x by itself. You divide by negative 3, divide by negative 3, cancel those out. You get x on this side, and you get 21 over negative 3, which is certainly negative 7. But in the middle, you change this from a less than or equal to greater than or equal to. So we can look back at the original to see why this makes sense. For example, you need to choose a number which is larger than negative 7, so you have to choose something like negative 6 or negative 5 or negative 4, because any of those numbers when plugged in will give you an answer which is smaller than 21. But if you chose a number that's actually less than negative 7, like for example negative 8, and you plug in negative 8 here, you can see that would actually be bigger than 21 and it would no longer hold. So flip the inequality when you divide by a negative. Second thing, graph the answers to a single variable inequality on a number line. So if your answer is x is greater than 2, that's going to go on a number line. You want to put in the 0, you want to put in the answer, which is 2. You want to use an open circle or a closed circle, so in this case open circle, because it's just greater than, not or equal to. And then shade left to right, so in this case x is larger, we're going to shade to the right. So one variable, one axis. On the other hand, if you have a two variable inequality, so for example y is less than or equal to x minus 3, because I have two variables, I need to make my answer a two variable answer, which means I need a coordinate plane with both the y variable and an x. So I graph this by using a solid line because of this, with an intercept of negative 3 and a slope of 1. So intercept of negative 3, slope of 1, solid line, and now y values which are less than this, so I'm going to shade below the line. So there's an unlimited number of coordinate points. All the coordinate points down here satisfy this inequality. For example, if I plug in this point, let's call it 5, negative 5. So if I plug in the point 5, comma, negative 5, to this equation here, I plug it in, I get negative 5 as the y value, is less than or equal to 5 minus 3. And 5 minus 3 is 2, right? So negative 5 is less than or equal to 2. Of course, that's definitely true, because this point is here in the shaded region. Anything above it, up here, would not be true. If I plug in these coordinate points, any coordinate point up here, if I plug it into this inequality, I would get something out which is false. Okay, a couple more things here. For compound inequalities, remember a compound inequality is more than one simple equality joined by the word and or the word or. Okay, so if the word is and, your final answer is just where the two inequalities overlap. But if the word is or, you keep everything from both. So typically your answer with an or will be a larger region, and your answer for an and will be a smaller region. It's more restricted. Okay, moving on. Absolute value bar problems require you to branch to two different possibilities. When you branch, you should remember the mnemonic. If it's some absolute value stuff is greater than, use or. If it's less than, use and. So greater or is or, less than is and. And of course also remember that when you take your one branch, which is positive, keep the sign the same, the inequality sign the same. But when you take your negative branch here, because it's negative, you have to flip the inequality. So just like always when you multiply or divide by a negative, the negative branch of your absolute value problem has a flipped inequality. And then the last thing for this summary video, a quick recap, is less than and greater than. These two symbols, they mean the solution does not include the point or line. So remember, greater than or equal to and less than or equal to, that bar underneath means or equal to, which means that point or that line itself is part of the solution. However, if you don't have that line underneath, and you just have one of these two symbols, the point or line itself is not an answer, and therefore we use an open circle or a dotted line to indicate that the point or line itself is not part of your answer. It's just the border between your answer and all the other points that don't work. So I hope this was a comprehensive and useful summary, even though it was really quick. You can review any of the individual videos, of course, if you have specific questions, or you can ask in class. Alright, good luck studying.